Welcome back. In this unit, we are diving into the heart of programming, logic with control flow and collection types. So let's break down these concepts into bit-sized pieces to understand how they help us to create dynamic applications and games. So, what is a control flow? Imagine you're directing traffic at a busy intersection. Depending on various conditions like the time of the day or traffic light signals, you decide which way the car should go. In programming, control flow is just like that. It helps us direct the execution of code based on certain conditions, whether it's opening a folder with a click or responding to a keyboard input. Control flow is the unseen director behind the scenes, and we'll discuss about control flow in programming uses selection statements to make decisions, much like choosing a path in a game based on the player's decision. So uh, basically the selection statements are if else statements that allow your program to execute different code blocks based on certain conditions. It's like choosing whether to wear a jacket based on the weather. So as we discuss further, we will encounter collection types, the containers that hold multiple values in a single variable. Think of them as a backpacks of your adventure, where you can store various items you'll need along the way. So we'll discuss more about it. Basically, the collection types are arrays. Imagine an array as a row of mailboxes. Each box can hold a letter, and you can access each one by its address. So we'll also discuss about dictionaries. Dictionaries, they are like phone books, which where you can look up a person's number using their name. So each entry maps a unique key to a value. And we'll also discuss about lists. Picture a notepad where you can add, remove, or change the order of your notes. Lists are flexible collections that can grow or shrink as needed. And we'll also discuss about iteration statements. So to navigate through collections or repeat actions, we use iteration statements. These are your loops that paths you walk repeatedly until you reach your destination. So for each loops, they are perfect for walking through each item in a collection, like checking every box in your row of mailboxes. And while and do while loops, these keep the action going as long as a certain condition is true, like continuing to move forward until you hit a stop sign. And we'll also discuss about controlling execution flow. Sometimes you need to make a early exit or skip a step. This is where execution control keywords come into play. Some of the execution control keywords are break, continue, and return. So break immediately exits the loop, like finding a shortcut. And continue skips the rest of the loop and starts the next iteration, like and return exit the method entirely, sending you back where you came from. So lastly, we'll discuss about how to avoid or fix infinite loops, the coding equivalent of running on a treadmill. It's crucial to ensure your loops have a clear end, or you might find your program running endlessly. So understanding control flow collection types is like learning to navigate and pack for your programming adventure. With these tools, you are ready to create applications and games that responds intelligently to user inputs and efficiently manage data. So our first topic is selection statements. So we are going to unravel a fundamental concept in programming that lets our games and applications make decisions. So selection statements. Imagine you're playing a video game and you come to a door that requires a key. If you have the key, the door opens. If not, it stays locked. So this decision making process in programming is managed through selection statements, primarily using if else statements. Let's break this down into simpler terms and explore how it works in a code. So at its core, if else statements are like crossroads in your games world. They ask a question, and based on the answer, the game decides which path to take. So think of the if keyword as a question, like do I have do I have the dungeon key. The condition inside the parenthesis checks if something is true. Let's go to Unity. Let's yeah. So this is how the syntax looks for the if else statement. So so basically this checks if the hash dungeon the if statement. This checks if the dungeon key is true. If yes, it executes the code inside the curly brackets. And what if the condition isn't met? So that's where else part comes in. It's the alternative path your game takes when if condition isn't met. So let's understand the logic of this program. So uh, let's this is a simple example in action. We have a variable has dungeon key that checks if the player has the key. And so in this code we are asking, do I have the dungeon key? If the has dungeon key is true, it prints the message allowing entry. If not, it prints the message of denial. So but but if there are more than two possible outcomes, that's where else if comes in. It allows us to check multiple conditions in a sequence. And you can use operators like greater than, less than, equals to compare values with these conditions. For example, if score is greater than 100, checks if the score is greater than 100. So an if statement can be standalone, and else if need an if to exist. So these statements guide the flow of your game based on the conditions being met or not. And the essence of selection statements, they are like the decision makers in your code, guiding your game's behavior based on certain conditions. Practice with different conditions and see how you can control the flow of your own games. So that's about. So we are going to have a bit of fun with if else statements by diving into a scenario that involves a character and their goal. So imagine your character walking through a market. So their purse is full or not so full of gold. We want our game to react differently based on how much gold the character has. So let's see how we can make that happen with some simple code. Let's go back. I already wrote the program for the examples so that I can save the time. So first we added a variable called current gold in our script. This represents the amount of gold our character has in their purse. For so let's for this example we have set it as 32, but feel free to play around with this number between 1 and 100. So next we are going to check the amount of gold and provide feedback to the player through debug logs. This is where if else statements comes into play. So we start by checking current goal is greater than 50. If it is, it logs a message saying that the character is rich and should be aware of pickpockets. If the character doesn't have more than 50 gold, we then check if they have less than 15. So so if so, we log a different message indicating there's not much to steal. And so finally, if neither condition is met, we fall back on the else statement. This is our catch-all used when current goal is between 15 and 50. We log a message saying that the character's purse is in the sweet spot, not too rich, but not too poor either. Uh, so so when we run this. So when we run this code with the current goal set to 32, this is what happens if the if statement, current gold greater than 50 is checked first, and since 32 is not greater than 50, we skip this part, and next it goes to, let's go back to, so next it goes to else if condition, the current goal is less than 15, again 32 is not less than 15, we skip this as well, and finally we reach to the else statement. Since none of the previous conditions were met, this block of code runs. We see our message about being the sweet spot in our console panel. So try changing the value of current goal to different numbers and observe how the output changes. This is a great way to get comfortable with the if else statements and understand how they control the flow of your code based on conditions. So yeah, there you have it. With a simple scenario and a few lines of code, we have seen how if else statements lets us create dynamic response in our game. So remember, programming is all about making decisions and responding to them, and if else statements are one of the key tools for doing just that. So the next topic is not operator. So we are going to dive into a super useful tool in our for our coding, the not operator, represented by an exclamation point. This operator allows us to check for conditions that are not true, which is just as important as checking for conditions that are. So let's break this down with some easy to understand examples. So uh, let's go back. So imagine you have a magic door that only opens if you have a dungeon key. Sounds a bit backward, right? Yeah, but in the world of games and programming, such scenarios are common. The not operator helps us deal with these situations, like flipping the truth value of a condition. So this is a basic look at how the here's a basic look at how the not operator look works in code. So in this example, uh, the not has dungeon checks if the has dungeon key is not true. If you don't have the key, if the has dungeon is false, the condition becomes true. So the message is displayed. This message will be displayed. So the line if not has dungeon key is saying, is if it's not true that the I have the dungeon key, since the has dungeon key is set to false, the not operator makes the condition true, and the code inside the if statement runs. So we can also use the not operator to check something does not equal to a certain value. So like for example, this part of the code. So here the weapon type is not equal to longsword. Checks if the weapon type is not a longsword. If you have another weapon, the code block will execute. So the not operator is all about flexibility. It allows us to create more perfect conditions in our games and applications, like setting up puzzles that only solve when certain items are not present, or triggering events when a player doesn't do something. So C sharp allows us to nest these conditions for even more complex logic. Imagine setting up a series of doors that only open based on what item a player doesn't have. Each door could have its own unique conditions to check against. So uh, I encourage you to use this code and play around with the values, change the hash dungeon key from false to true, see what happens, and try different weapon type values to see how the debug message appears. So this hands-on approach will help solidify your understanding of the not operator. So understanding the not operator is a key step in mastering control flow in programming. It opens up world of possibilities of creating complex, engaging logic in your games and applications. So keep experimenting, keep saying what if. You'll find yourself thinking like a programmer in no time. So the next topic is nested if else statements. Now we are going into the intricate maze of nested if else statements, also known as decision trees. These allow us to build complex logic with our games and applications. So let's discuss this concept with a simple yet relatable game scenario. So imagine your character is getting up for a grand quest. You can choose different weapons, each with its unique battle cry. However, they must have a weapon equipped to proceed. Our goal is to guide the character through these decisions using the nested if else statements. So let's go back to the Visual Studio. So let's dive into the example code and uh, have a better understanding about the decision making process. So our first if else if statement checks if the weapon equipped is true. Think of this as the outer door your character must open to access the armory. So if the character has the weapon equipped is true, we proceed inside the next decision. If not, we are going straight to the else part, where the game advises that fist won't be much help in battle. So so within the first statement, we have another if statement. This is our nested if. The second door asking is the equipped weapon a longsword. So uh, if the weapon type equals to longsword, our character proudly shouts for the queen, signifying they are ready for battle with the right weapon. Notice there is no else part for this for the second if statement. This means that the if weapon isn't a longsword, nothing happens. Our character stands silently, perhaps contemplating their choice of weaponry. So, why nesting matters? Nesting allows us to create a logical pathways, each depending on various conditions being met. It's like crafting a story where the plot branches based on the choices the character makes. So while this example focuses on a single nested if, you can imagine scenarios with multiple layers of nesting, each adding depth and complexity to your game's logic. So I encourage you to experiment with this code, change the weapon equipped to false or swap weapon type to something else like arcane staff. So observe how the logic flows. The hands-on experience is important for understanding how nested if else statements work. So nested else statements are powerful tools in programming, enabling you to guide your game's narrative and logic through countless scenarios. So with practice, you'll understand crafting in intricate decision trees that bring depth and interactivity to your games. So I'm not running the program. I want you to see this program and use it as a reference to do your own coding. So let's move to the next topic. So the next topic is logical operators and conditions. So we are going to discuss. We're going into the world of logical operators, like in programming, specifically the and or operator. So these operators allow us to check multiple conditions at one in our quest for coding. So let's explore this with a treasure chest experiment with to see how we can use these operators to navigate complex decision paths. So before that let's understand what's and all operators are. So and operator, think of this operator as a strict gatekeeper. For a gate to open or for the code block to execute, every condition it guards must be true. If even one condition fails, the gate stays shut. And or operator, this operator is more lenient. It's like having multiple keys to a gate. If any one of them works, I mean, if any one condition is true, the gate will open. So imagine we are in a game where opening a treasure chamber requires being a pure of heart, possessing a rare item, and knowing a secret incantation. So let's see our example. So here's how we set up our variables, and we'll check our conditions to see if we can open the we can open the treasure chamber. Uh, so the first if statement, we are using the AND operator to check two conditions. Is the character pure of heart, which is pure of heart is true, and do they possess a relic, a stone? The rare item is equal to relic stone. So both conditions must be true for the code to execute. If either condition fails, the else block is executed and the character is told to return what they are ready, when they are ready. So, and inside uh, we check if the character lacks the secret incantation for using the not operator on the has secret incantation. Since the has secret incantation is false, uh, so the not operator returns it true, executing the inner if block. So our character is a pure of heart and has a relic stone, meeting the first if statement's condition. However, they don't know the secret incantation, so the message about needing knowledge is displayed. So the logical operator allow us to make our code cleaner and more readable. Instead of a maze of nested if else statements, we can check multiple conditions in a single line. It's all about efficiency and clarity. So experiment with changing the values in your script. Observe the different outcomes. So basically, the hands-on practice is important for understanding and or and not operators. Guide the flow of our programs. So we have seen how logical operators help us navigate complex conditions with ease, making our making our code both powerful and elegant. So as we continue, remember that these tools are here to make your programming both manageable and enjoyable. So the next topic is switch. So we'll discuss about the powerful tool in programming, the switch statement. It's perfect for situations where you have several possible paths or outcomes based on a single condition. So let's dive into how you can switch. You can use switch statement to control a character's action in a game, making our decision logic cleaner and more manageable. So why use switch statements? Imagine you have a game character. Imagine your game character can perform different actions like attack, heal, or defend. If you try to handle this with if else statements, your code could quickly become a tangible mess, especially as you add more actions. So switch statement simplifies this by neatly organizing each possible actions. So a switch statement evaluates a variable, then jumps to the matching case statement to execute its code block. So let's go to the example. So this is how it looks like, the switch syntax. So uh, the switch the switch keyword, this this introduces the switch statement followed by a variable called character action in the parenthesis. Think of character action as the question, what action should the character take? That's the question. So each case uh, represents a possible value of character action and the action to take if the value matches. For example, if the the character action is heal, uh, the game will log the potion sent. So this tells the break keyword tells the program to exit the switch statement once a case is has executed, preventing it from running through the rest of the cases. And there's a default case. This is a catch-all case that executes none of executes if none of the other cases match. It's like saying if all else fails, raise your shields up. So so the here the switch statement checks the character action against each case. In our example, since character action is attack, it matches the uh, second case, executing its code block and logging two arms to the console. So yeah, again change the character action to heal or defend or something entirely different to see how the switch statement handles each scenario. This is a great way to understand how each case is selected and executed based on the condition. So why this matters? Because the switch statements make your code cleaner, more readable, and easier to manage, especially when dealing with multiple possible outcomes based on a single condition. They are essential parts of writing efficient and effective code in game development and beyond. So uh, it's a straightforward way to handle complex decision making in your games using switch statements. So as you practice, you'll find them invaluable for navigating the many paths of your code can take. So yeah, keep experimenting. So the next topic is fall through cases in switch statements. So we'll discuss about intriguing feature of switch statements, uh, which is fall through cases. This concept allows us to streamline our code, making it more readable and efficient, especially when multiple cases lead to same outcome. So let's explore this with a fun tabletop game scenario involving a dice roll. So before going to an example, let's discuss what fall through cases actually mean. Imagine you're playing a game. When you roll a dice to determine your character's attack outcome. Some rolls might result in the same action. Instead of writing a separate code for each, you can use the fall through cases in a switch statement to group these outcomes together. So let's go to the example. So our character rolls a dice, and based on the number, we determine the attack's effectiveness. A roll 7 and 15 results in a mediocre damage, and roll of 20 results in a critical hit, and any other roll is a miss. So we start with an integer rice roll. Uh, Simulating our dice roll outcome. So it's set to 7 for demonstration. So uh, the switch checks the value of dice roll and matches it with the case statements. So the fall through case for 7 and 15. Notice how the 7 directly falls through the to case 15. This means if dice roll is 7, doesn't have its own action or break uh, keyword, so it falls into next case, which is 15. Both 7 and 15 share the same outcome, mediocre damage, not bad. So there's another unique case, 20 case for 20. Rolling a 20 triggers its own unique message about a critical hit. And default case, any roll that doesn't match 17, 15, or 20 results in missing, triggering the default case message. So fall through cases uh, make our switch statements more effective, and our intentions clear. Instead of repeating the same actions for different cases, we group them, reducing redundancy. So yeah, again, try changing the dice roll value to 15 or 20 and observe the outcomes. So fall through cases in Switch statements are like shortcuts to our code, allowing us to direct multiple conditions to the same outcome efficiently. They are especially useful in games for handling various scenarios with similar results, making our code cleaner and more manageable. So keep playing around with this concept, and soon you'll understand about. You'll become a pro in fall through logic. So that's the last topic for this video. I'll see you all in the next video. Thank you for watching, and don't forget to subscribe and like.